I'm Lorin, and I'll jump right in. So our work was heavily inspired by a paper entitled The Intrinsic Memorability of Everyday Sounds, in which the authors conducted a memory game similar to the one in this task, except on sounds, in which they found that high-level features such as imageability, arousal, familiarity, and human causal uncertainty correlate highest with sound memorability, and they called these audio Gestalt features. As for our approach, there are 1,500 videos in total, 510 for the initial development set and 490 for the supplemental development set, with 500 left over for testing. For our development, we kept 800 for training and 200 for validation. We decided to generate our own short-term ground truth scores since the 490 supplemental development set didn't have actual short-term ground truth scores. And to do this, we collaboratively filtered the reaction times for each user video combination. We defined a hit as a reaction time of 0 to 4,100 milliseconds, which is within 2 standard deviations of the mean reaction time, and then calculated the new ground truth scores as percentage hits. So for our actual approach, we pre-computed audio Gestalt features for each video, and then depending on the audio Gestalt levels, we went with an audio stream or without audio stream. The audio stream has 3 independent models: an XResNet 50 frame-based model, an XResNet 34 audio-based model which uses a 3-channel spectrogram, and an AWD LSTM augmented caption model, which has task captions that have been augmented with audio tags that are appended to the end. The without audio stream is simply 2 models, an XResNet 50 frame model and an AWD LSTM caption model. And the final scores for each respective stream are simply a weighted sum of their constituent models. So why did we choose audio Gestalt? Well, when we were participating in the memory game for this task, we noticed that audio was helping us remember videos more quickly. So we read through some of the literature and found that multisensory experiences do indeed exhibit increased recall, and that sounds provide contextual priming information. So we thought that we might as well explore it in a task like this. Here are our pre-submission results, which were on 200 validation videos. You can see a key that's color-coded on the left, which highlights what models went into each of the runs. What's most interesting here is our run 4, which is the audio Gestalt system that we described, seems to perform best, which confirms our hypothesis. But unfortunately, in our official results, as you can see, run 3, we're missing short-term validation scores, and that's because of a mistake in our submission procedure, and unfortunately we just don't have those scores. However, what is quite interesting to notice is that run 1, which was our audio-only run, had the longest or the highest long-term score, and that Memento 10K, which was a throwaway run and which was trained on no task data at all, has our highest short-term Spearman score. So I guess in conclusion, our generated ground truth scores seem to be quite good, and that they didn't negatively affect our Spearman scores in the end. What was most shocking was that our model that was trained on no task data performed best, and our conditional audio Gestalt-based system seems to be quite promising from our pre-submission results and our short-term official results, and we would like to explore it further in the future. Thank you very much.